Alright, let's do some of the problems in 15.5. First off, let's look at number 2. Okay, this is in our text. And number 2 says use the chain rule to find dz dt or dw dt, and z is the square root of x squared plus y squared. So dz dt is the partial of z with respect to x times dx dt plus partial of z with respect to y times dy dt. So dz dx is 1/2. You have to use a chain rule. Subtract 1. Come back, take the derivative with respect to x. So that's 2x, y is a constant, times dx dt. Plus do the same thing with respect to y. X is a constant here, so it's 2y times dy dt. And so we have x over the square root of x squared plus y squared dx dt plus y over the square root times dy dt. Okay, and we're done. We just use the chain rule for that. Oh, I forgot. Okay, no, we're not done. X is a function of t, so x in this case is e to the 2t, so dx dt is 2 e to the 2t, and y is e to the minus 2t, so dy dt is e to the minus 2t times minus 2. So we can factor out a 2 e to the 2t over the square root of x squared plus y squared. And we have left, when we substitute this in here and this in here, we have x minus y. And now we're done. We can't factor out a u to 2t. Okay, I'm sorry. Because y is e to the minus 2t. So, well, we could, but it'll be a little more complicated. Let's just leave it like this. That's better. Okay, 10. Okay, we want to find partial of z with respect to s. So we do s with respect to x times x. We do the partial of x with respect to s. Let's see. Plus z with respect to y, y with respect to s. So the derivative of z with respect to x, that means y is a constant. So tangent y is just a constant. E is itself times derivative of the exponent, but y is a constant, so it's just y. Dx dx is the derivative of this with respect to s, and that's just 1. And then the derivative with respect to y, x is a constant, so we have e, we have to use the product rule. E to the xy derivative of tangent is secant squared. Derivative of e to the x is xy is itself, but we're taking it with respect to y. So x is a constant, so we need an x there. And again, that's just the product rule. Then the derivative of y with respect to s is this. T is a constant, so that's just 1 over t. Now, dz dt is the same thing, except we do x with respect to t and y with respect to t. So partial of z with respect to x we've already done. Let me put it in a good order. That's just this. Derivative of x with respect to t is 2. That's the derivative of that. Okay, this is the same. And the derivative of y with respect to t. So s is the constant. We take the derivative with respect to t, and we get negative s over t squared. So this is the same. And we are done with that. Okay, let's look at 14. W is a function of s and t, and f is a function of u and v. So w with respect to s is partial of f with respect to u times u with respect to s plus f with respect to v and the partial of v with respect to s. And we want to evaluate that at the point 1, 0. Okay, this is given as -2. This is given as 5. So we need to find f of f with respect to u. Well, f at u1, 0 and v1, 0 is, let's see, f of 2, 3, and that is -1. Wait, we don't know. We'll say f of u. And f of v of u1, 0, v1, 0 is f of v at 2, 3, and in the book they give that as 10. So this is -1 from here, and this is 10 from here, so our answer is 52. And w with respect to t is partial of f with respect to u times u with respect to t, partial of f with respect to v times v with respect to t. And if we plug in 1, 0, again, these are going to be the same. So this we found was -1, and this was 10. The book says u with respect to t is 6, and v with respect to t is 4. So this comes out to be 34. Okay. 18. If w is a function of x, y, z, we want to do a picture, and x is a function of t and u, y is a function of t and u, and z is a function of t and u. And the picture is like this. W is a function of x, y, z. It's a tree diagram. X is a function of t and u, and this should help you set up the chain rule. That's the point of that problem. It'll help you decide what depends on what. Okay, let me go to a new page. 24. Okay. We know u is 3 and v is -1. So that tells us that this is -6, this is 4, and this is 2 at that point. And what we have is m with respect to u is m with respect to x times x with respect to u plus m with respect to y times y with respect to u plus m with respect to z times z with respect to u. So the derivative of this, well, y and z are constants, so the derivative of x is 1, so we just get the rest of this. Derivative of x with respect to u, v is a constant, so that's just 2v. Now do it with respect to y, x and z are constants. And then y with respect to u is 1. And with respect to z, take the derivative of the exponent. And z with respect to u is 1. So when we plug the numbers in, we get e to the 0 times -2 plus -6e to the 0 times 1 plus x, which is -6e to the 0 times -4. So we have -2, -6 plus 24. And that is 16. Okay, m with respect to v is mx xv plus my yv. And again, these are the same. Almost. The m's are the same. And when we plug in the point 1, 0, that's e to the 0 times 6 minus 6 e to the 0 minus 1 plus minus 6 e to the 0 minus 4, and that's 6 plus 24, and that's 36. Okay, 30. Okay, so fxy bring everything on one side. We have to have that equal to 0. Then what we want to find is dy dx. So remember the implicit function theorem says that's just the function, the derivative, the partial derivative of f with respect to x over the partial derivative of or over with respect to y, and it's negative. So derivative with respect to x, derivative sine is cosine, y is a constant, so the next one's 0. This is the, no, we don't need the product rule, derivative cosine x, cosine y is a constant, so derivative of sine x is cosine x. With respect to y, 0. So this is going to be cosine x times cosine y minus 1 over sine y sine x minus 1. That's it. Okay, 38, we have a cone. The volume of a cone is 1/3 pi r squared h. I want to find the rate of the volume, that the volume's changing. The height's decreasing, so the radius is increasing, so it's positive, and that's not a partial, that's a derivative because h only depends on time. And the height's decreasing, so it's negative. So dv dt is pi, oh, I'm going to do, it's v with respect to r times dr dt plus v with respect to h times dh dt. So v with respect to r is that, and with respect to h, times dr dt, but we know what that is. With respect to h, we just get all that, that's constant. And now we just substitute numbers in. The radius is 120. The height is 140. And when we work it out, and don't forget the units, it's volume over second. It's, because it's dv dt, this is volume, change in volume over the change in time. So the units are volume over time. Okay, that should help you with your problems.